Food wastage is a worldly problem in the more affluent nations. However, did you know that every day Malaysia throws more than 38,000 tons of edible food daily?
There are several causes of food wastage, but the major contributor to this waste is unconsumed and spoiled food. Definitely, this does not meet the aim of circular economy and cannot fulfill SDG 12 responsible consumption and production.
One way to reduce the amount of food waste is Eco-enzyme. Eco-enzyme, also known as garbage enzyme, is the fermentation byproduct of fresh organic waste serving as fertilizer and cleaning agent. Recent evidence shows that Eco-enzyme is capable of improving water quality by decreasing biochemical oxygen demand and chemical oxygen demand. At the same time, dissolved oxygen level can be increased. It also efficiently removes total suspended solids as well as killing bacteria. Effective decrement of total suspended solids after only 10 days. On-site application proved that water quality was improved within a month. Furthermore, it also helps to reduce cadmium encapsulating the root of plants. In this project, we are going to present to you a field test to the application of Eco-enzyme in removing suspended solids from the 3 ponds located in Taman Pelangi Indah, Ulu Tiram. Based on the Interim National Water Quality Standard, all the ponds possess the same water quality where pH and chemical oxygen demand are of class 2, dissolved oxygen, biochemical oxygen demand, and ammonia are of class 3, and only total suspended solids is of class 1. But owing to the small sized particles, the suspended particles cause the water to be turbid and cloudy.
In a healthy pond, 3 biological processes which are aerobic, anaerobic, and anosmic will occur. The aerobic process helps remove the organic waste and ammonia to form new cells. While during the anaerobic process, the organic waste will transform into organic acid, ammonia, and hydrogen sulfide. The organic acids from anaerobic process will react with nitrate from the aerobic process to form nitrogen and the carbon dioxide. This is known as anosmic process. The hydrogen sulfide then react with oxygen forming harmless sulfate. Iron is an essential macronutrient in the chlorophyll formation of plants. Plants can only absorb iron 2. Under a balanced iron cycle, soluble iron 2 react with oxygen to form solid iron 3 oxide. When depositing at the root of plant, solid iron 3 will reduce to solid iron 2 in the presence of lactate ion and/or acetate ion in the absence of oxygen. However, an imbalance triggers when there is a max influx of soluble iron 2 into the environment. Without sufficient lactate and acetate ion, solid iron 3 cannot be transformed into solid iron 2. Once deposited on plants, it causes iron plaque that lead to plant death. The color of the pond water will remain orange and have a rusted smell. As an eco-enzyme contains a high amount of acetic acid, it will greatly help the transformation of iron 3 to iron 2 solid. Before pouring, an on-site analysis on the efficiency of eco-enzyme to settle the suspended material is added. Drastic visual changes occur within 24 hours.
In the top chart below, the yellow bar represents the rainfall depth, whereas the blue, green, orange, and red represents the day of pour. The eco-enzyme is poured daily during the first 12 days, followed by 3 days once, and then weekly pouring. The total suspended solids concentration of each pond decreased to nearly 0 at day 41. Through the observation, for pond 1, the floating substance vanished and the clarity of the pond remains high, while for the pond 3, the bulb regained visibility on the day 41.
Chemical oxygen demand has shown a decrease in day 41.
While BOD has also shown a good result of decrement. For the ammoniacal nitrogen, day 26 has high concentration due to the heavy rainfall on day 24. Knowing that the flow of water is from the first pond and the second pond to the third pond, plus there is no discharge of water from the third pond, it directly causes the ammoniacal nitrogen value to increase drastically, but it returned to 0.2 mg per liter on day 41.
pH value and the dissolved oxygen of the pond water remains more or less the same due to the influx of iron containing groundwater.
There is a reduction on the dissolved oxygen as the reduction of the iron takes place.
For the first pond, generally the water quality classification has increased with total suspended solid, chemical oxygen demand, and ammonia at class 1. Biochemical oxygen demand level at class 2, pH remain class 3 as there is a huge downpour during the 23rd and the 24th day. On the other hand, for the second pond, similar results can be identified. Total suspended solid and ammonia enhanced to class 1, chemical oxygen demand at class 2, and again, pH and the biochemical oxygen demand was affected by the huge downpour of total of 28 cm increment of lake depth. And for the third pond, the best results can be identified as total suspended solid, chemical oxygen demand, and biochemical oxygen demand has increased to class 1, ammonia to class 2, and again, the pH was affected by the huge downpour. The residents who are not involved in this project has responded that there is a significant improvement of the quality of the lake visually.
We, therefore, can confidently state that the achievement of SDG 6 clean water and sanitation would require different partnerships in attaining the goals as stated in SDG 17. With this, transforming Malaysia into sustainable city and communities and producing communities heading towards responsible consumption and production is not too far away.